Hi, I'm Miss Hearn. Let's get started. In this video, we're going to talk about restricted values and simplifying rational expressions. Before we do, there are a couple of important facts that we need to know. First of all, what's a rational expression? Rational expressions are ratios. That's where the name rational comes from. They're ratios or fractions that happen to have some variables in them. So we're used to fractions like 5/6, but we can also make fractions that have variables in them, like maybe x over 2x or a minus 2 over a plus 2. So everything that applies to a regular fraction still applies to a rational expression. So we're going to be able to reduce them or simplify them. But we do have to be careful because when you have a variable in a rational expression, you have to be careful of what values are actually allowed. For example, in this case, if I were to plug in the value -2 for a, something strange would happen. We would have -2 minus 2 over -2 plus 2, which would be -4 over 0. And division by 0 is undefined. So any number like -4 over 0 doesn't make sense. You can't divide a number by 0. So one easy way to remember that is that a number, and we're going to use n for number, divided by 0 spells no. You can't divide a number by 0. Now, that's not true the other way around. For example, 0 divided by 5. It makes sense to divide nothing into 5 piles that you get nothing. So it's okay to divide 0 by a number. To remember that, 0 divided by a number equals right on. You can do it. All right, another thing that we need to remember and realize is since these are just fractions we're talking about, they can possibly be reduced by dividing out common factors. They can also be reduced by dividing out opposites, but we'll talk about that in the next video. So you're probably familiar with reduction or reducing problems like simplify 6/10. You probably know you can divide the numerator and denominator by 2. The reason is because if you write 6 as a product of its factors and 10 as a product of its factors, you can see they have what's called a common factor. Factors are just things that are being multiplied. And the common factor here is 2. And 2 divided by 2 is, of course, 1. So we just have 3/5 instead of 6/10. Now, this applies to rational expressions as well as regular fractions. So maybe the common factor is a variable, like the expression x over 2x. This rational expression has a common factor in the numerator and denominator of x, right? X is just being multiplied by the 2 in the denominator and multiplied by 1, although it's not written in the numerator. So if we divide x by x, that leaves a 1, and we just have 1/2. So let's go ahead and start by looking at rational expressions and their restricted values, values that are not allowed, also called excluded values, and then we'll talk about reducing them. So if I asked you to find all the excluded values for the expression, what I'm saying is what values of t would make the denominator turn out to be 0? Remember, division by 0 is not allowed. So we would set the denominator equal to 0, and we would solve for the value of the variable that would make that expression equal 0. In this case, I would have 2t plus 8 equals 0, and to solve that, I'd get t by itself. So I'm going to subtract 8 from both sides, keeping the balance. So we have 2t equals -8. Now that t is being multiplied by 2, so the opposite operation is to divide. So we're going to divide both sides by 2, and we're going to get t is equal to -4. So what is it that we just found? We found the one number that t is not allowed to equal, the restricted value -4. Why is it not allowed to equal -4? Because if we plug in a -4 into the expression for each t, let's see what happens here. In the numerator, we get negative 40 minus 1, which is negative 41. And in the denominator, we get negative 8 plus 8, which is 0. And division by 0 spells no. So you can't do it. Notice I did not set the numerator equal to 0 because it's okay for 10t minus 1 to equal 0. It's just not okay for the denominator to be 0. So when you're asked to find the restricted or excluded values, set the denominator equal to 0 and solve for the variable. Let's try it again in this one. Here we have 4 over 15 plus 3v. Set 15 plus 3v equal to 0 and solve for v. This is a linear equation. We can solve it by just isolating the variable. So we're going to have 3v equals negative 15 when we subtract 15 from both sides. And the next step is to divide both sides by 3. So we're going to have v equals negative 5. Again, this is exactly the value of v that is not allowed. You can never plug in negative 5 to this expression because you get an undefined result. All right, one more of this type. Let's look at something a little bit more complicated. So if you've already learned how to solve quadratic equations by factoring, you should be able to work this problem as well. So in this problem, we have t squared plus 8t plus 7 over t squared minus 1. Again, we're asked to find the excluded values, which just means the values of t for which the expression is undefined. So we set the denominator equal to 0. Denom equals 0. In this case, the denominator, the bottom of the fraction, is t squared minus 1. So we see at this point that we have a power of 2 on our variable here, which means that this is actually a quadratic equation. And in my class, the only way we've learned so far to solve a quadratic equation is by factoring. It may be that in your class you've done something different, and you could always do that as well. But if we factor, and by the way, it's important that we have 0 on one side of the equation, because that means we have standard form, which is very helpful. If we try to factor the left side, we see that we have no greatest common factor between the terms, and we have two terms, which means that it either has to fit the pattern of a squared minus b squared, a cubed minus b cubed, or a cubed plus b cubed in order for us to be able to factor over the integers. So we are going to recognize that it is a difference. So it's either a squared minus b squared or a cubed minus b cubed, or not factorable. And in fact, it fits the pattern of something squared minus something squared because 1 is also a perfect square. So a squared minus b squared factors into conjugates. It's always going to be the same two terms, the t, the 1, the t, the 1, but with the opposite signs in the middle. The reason why this is a nice form to have the equation in is because essentially we have two mystery numbers, right? One has the name t plus 1, one has the name t minus 1. They're being multiplied together to give us a result of 0. And the only way that can happen is if one of those mystery numbers is actually 0. Right? You can't multiply two non-zero numbers together and get 0. So setting each factor equal to 0, we have t equals negative 1 or t equals positive 1. And again, what we just found are the two values that t is actually not allowed to equal. These are the restricted values. If you plugged them into the original expression, it would cause the denominator to be 0. All right, the next thing we're going to talk about is we're going to shift gears a little bit and talk about reducing fractions when they are actually rational expressions, when they have variables in them. It works the same way as reducing a regular fraction. You want to divide out common factors. So having the rational expression in factored form, as this one is here, is really helpful. The reason why I'm calling it factored form is, remember, factors are just things that are being multiplied, and outside of the parentheses, the only operations that are occurring are multiplication. So this is considered to be in factored form. In other words, if there were, say, a plus or a minus in between these parentheses, it would not be factored because there'd be an operation other than multiplication. But no, in this case, we have a factored form. And so what we can do is divide out common factors. So what common factor do you see here? I see a 2u plus 5 in the denominator and a 2u plus 5 in the numerator. So I can divide that by itself, and that just leaves a 1. And also 5 and 30 have a factor of 5 in common. 5 goes into 5 once, 5 goes into 30 6 times. So we can reduce this down to u minus 5 times 1, although you don't have to multiply by 1. That's just going to be u minus 5. And then in the denominator, we're just left with 6 times 1, or 6. So this expression actually reduces down to u minus 5 over 6. Now, what if somebody had asked us for the restricted values? You would have to look at the unreduced, let's say, look at the unreduced form, the form before you reduced. Don't wait until the end, because if you look at the end, it looks like there's no restricted values because there's not even a variable in the denominator that could possibly cause it to equal 0. So if you were to look for restricted values, you'd have to go back to this form up here. Now, this particular problem did not ask me for the restricted values, but sometimes they will. They'll ask you both to reduce and to find the restricted values. And if you make the mistake of reducing first, you're going to think there are none because 6 cannot equal 0. That can't happen. But notice that in the original expression, we had the factor 2u plus 5, and that could equal 0. So we would set the denominator equal to 0, divide both sides by 30, you get 2u plus 5 equals 0. Subtracting 5, we'd get 2u equals negative 5, and dividing by 2, we would get u equals negative 5 halves. This would be a restricted value. So again, one more time, when you're finding restricted values of rational expressions and you're simplifying, just remember to find the restricted values first. All right, now let's simplify one more rational expression. This one's different than the previous one because the previous one was already factored for us. Now, a lot of times when people see an expression like this, they think they can start reducing. Look, it looks like common factors. Y goes into Y, but in fact, that's not true because this is not in a factored form. Not in factored form because we have operations going on outside of parentheses. That is not multiplication. So let's put it in factored form. We know how to factor. So we're going to look at the numerator, and remember, when you factor a polynomial, you always look for a GCF first. So what's in common to 4y squared and 24y? Well, 4 goes into both 4 and 24. Y goes into both y squared and y. What do you multiply 4y to get 4y squared? Just y. What do you multiply 4y by to get negative 24? Y, just negative 6. And in the denominator, we want to see what's in common to 3y squared and negative 18y. That would be 3y. And what's left behind is also y minus 6. So let's divide out. Now that we have factored form, we can go ahead and reduce, dividing out identical or common factors. Y minus 6 divided by y minus 6 is just 1. Y divided by y is 1. So we're left with just 4/3. I hope you found this video helpful. If you did, please remember to like it. If you give it a thumbs up, it helps other students to find the video.